Apparently, physics unit 1 is cooking AS students. So I'm going to show you idiot sandwiches how to actually solve unit 1 papers. So let's get into the video.
What are you?
An idiot sandwich.
Idiot sandwich what?
An idiot sandwich, Chef Ramsay.
Okay, so I chose a paper October 22 physics unit 1. Let's see the first question. Which of the following quantities is given by the area under a velocity time graph? What? Man, even my unborn kid can solve this. Area under velocity time graph, it is displacement. Okay, next question. Which of the following quantity is a vector? Wow, very nice question. Energy is a vector. Oh, mass is a vector. Power is a vector. No. Momentum is the only vector here. Next question. Which of the following best describes the situation in which Stokes' law applies for object moving in a fluid? What is Stokes' law? Stokes' law is when drag force you can write as 6 pi r eta and velocity terminal. That means this is the drag force. When can you do this? When the object is spherical, when the object is small, when the flow is laminar, and when it moves with less speed. So these are the 4 points for obeying Stokes' law. So in here they gave a small spherical objects moving at low speed as an option. So this is the answer. It must be small, it must be moving at low speed, it must be spherical. So all 3 criterias are maintained. Okay, next question. A car is accelerated along a straight road. The graph shows how the acceleration of the car varies with time. Which of the following graphs show how the velocity of the car varied over time in the same interval? Okay. Velocity time graph, the gradient of velocity time graph gives acceleration. So if you observe the gradient, at first it is very high gradient. The gradient is very high. So at first gradient is very high, and then the gradient gives acceleration. The gradient of velocity time graph gives acceleration. So for the first graph, the gradient is very high at first, and then maximum gradient at first, and then the gradient slowly decreases, eventually becomes 0, and then it again increases. Gradient starts increasing but negative direction. That means the values will be negative. So we are observing this here, exactly same thing, that at first it is decreasing, gradient acceleration, gradient is decreasing, meaning what? Acceleration is also decreasing. Acceleration decreasing, and at one point reaches 0, and then gradient increasing but in negative direction, meaning acceleration also increases but value is negative. Because why? Gradient here is negative. But this is such a complicated concept. Why will I use this? As an A-level student, I know that if I want to go from one graph to another, that from displacement time to velocity time, I can differentiate it, and from velocity to acceleration I can differentiate it. So let's see, this looks like a quadratic curve, x square. If I differentiate, it comes linear, 2x. So this is the answer, there is no other option. So all of these are wrong. A is the answer. Next question. A sample of material is in the form of a wire. The material has a large value of Young modulus. Large value of Young modulus. Young modulus I think represented with y, fx divided by a del x, or even simpler you can tell, stress by strain. Now let's see what they want. Which of the following statement best describes the material? It has high Young modulus. That means high value of stress, low value of strain. The large force per unit cross-sectional area is required to break the wire. A large force is required. That means what? What they mean is large force per unit cross-sectional area. That means they are telling that stress is large stress is what? Force by area. That is, they are telling large force per unit cross-sectional area is required to break the wire. That means they are telling stress is high. But we cannot come to a conclusion yet because they did not tell anything about the strain. So we are keeping it here. Next question, the mass, next option, the mass per unit volume is large. That is something not related to Young modulus at all. Ratio of tensile stress to tensile strain is large. Yes, Young modulus is stress by strain. If the ratio is large, Young modulus is large. So this is more preferred option. After removing a large stress, the sample returns to its original length. This has nothing to do with Young modulus. So either this or this. Now I am saying that this one is more accurate. So number C is the answer. Okay, next question. A rubber band is initially stretched by an increasing force. When the force is gradually decreased, the rubber band returns to its original length. Okay, good. P, Q, R represents different area of the graph. Automatically I can tell that P is some stupid area. It is meaningless. That P has no effect, no relationship with any energy, any value, any physics related concept here. P is just some random area above the graph. Area above the graph does not give anything normally. So area below the graph we will see. So either Q, R or both of them added, they will tell us question like this. P, Q, R represent different area of the graph. Which of the following is the work done in a stretching rubber band up its maximum extension? That means after you extended it, so it came somewhere here. The area under this part, it is your work done. So work done's formula, normally if it was triangular, half into force into extension. Otherwise you have to calculate the number of boxes if you guys did question paper. So in here up to this area under the graph, so Q is also area under the graph, R is also area under the graph. So Q plus R. Anything with P is rejected. Q is not the answer because they did not tell it returned back to its original position. If it returned back, then you could tell yes, Q is the stored energy, but Q is not. And only R is also meaningless. So Q plus R is the answer. Okay. Two forces X and Y act on a point. Which of the following vector diagram? In this is actually too easy for me to solve, but still I am doing. Anyway, so I know that head to tail connection it has to be. Look, this is tail connection cut. This is tail connection cut. Only two options with head to tail. Head tail resultant is this way. So it has to be correct. Look, head tail resultant the other way. How is it possible? A person went rightward, downward. So must mean it went this way. Common sense. So C is the answer. Next question. When a certain spring is stretched by a tensile force F, the elastic energy stored is E. So if I take a spring and if I give a force of F, so the energy stored, energy's formula is what? Half times force times extension. Half times force times extension. So in this case they told the value is E. So half F del X, this value is E. That is what they mean. Now they told the three springs are arranged in parallel. Now you will learn a new thing. When springs are arranged in parallel, the stiffness constant gets added. So stiffness constant, it will get added. So it will be 3K now. Stiffness constant will be 3K and it is 2F force. So if I wrote this one also in terms of K, let's say I took the extension in terms of K. So normally formula is F equal to K del X for one spring. So del X value will be what? K by F, sorry, F by K. So if I rewrite this one del X, instead of del X, energy I can write half times force times F by K. So it is just F square by 2K. This is my energy value for normal one spring energy value, but it is three springs here. So now if I do F equal to K del X, now F is 2F. So 2F equal to K times del X. If I make del X subject, del X will be now 3K, because three of them the stiffness constant get added in parallel. So it will be 2F by 3K. Now energy will be what? Energy, let's say this is energy 1, let's say. So now new energy will be half into force into extension. Now force is 2F and extension is this 2F by 3K. So I can cancel out these two and these two. So it is ultimately 2F square by 3K. It is remain 2F square by 3K. So now this is my normal energy and this is my new energy. Let's name it energy new. If I make a ratio out of them, energy by energy new, if I divide it, then I can get one in terms of another. 2F square by 3K divided by, sorry, energy by energy new. So F square by 3K, F square by 3K divided by 2F square by 3K. It was F square by 2K. It's not 3K. F square by 2K. My handwriting I did not recognize. F square by 2K and 2F square by 3K. Now if I do division, F square by 2K multiplied with 3K by 2F square, F square out, K out. So E by E new, it is how much? 3 by 2. So now they want 3 2s are, sorry, multiplied with 3 by 2, so 2 2s are 4, sorry, 3 by 4. And now if I cross multiply, that means E nu will be, I have to find E nu in terms of E, isn't it? So 3 E nu equal to 4 times of E, so E nu will be 4 by 3E is my final answer. See, they gave it as an option. Yes, this question is a bit tricky, but let's say you did not solve it, so only 1 mark gone in the MCQ part. Next question. A proton and an electron have equal kinetic energies. The speed of the proton is v. The mass of the proton is 2000 times mass of electron. So mass of proton, it is 2000 times mass of electron, and kinetic energy, they are equal. So half into mass of proton into velocity of proton square equal to half into mass of electron into velocity of electron square. Now that all mass of proton is 2000 times greater, so let us substitute it. Half into 2000 times mass of electron into velocity of proton square. That all speed of the proton is v, so no need to write vp, I write only v. So v square equal to half into mass of electron into velocity of electron square. So now I know that me I can cut, half I can cut. So velocity of electron square will be 2000 times velocity square, that means velocity of proton. So velocity will be root over 2000 into v. That is my final answer, A. Okay, energy dissipated, that means I want the wasted energy. So I know that amount of energy wasted, it is how much, 52% efficient, that means 48% remains. So 0.48%, 0.48 of the total energy is my wasted energy. So I want this value, I want the wasted value. So now in terms of number, that means I have to create another equation since 2 variable. So another equation I can make is useful energy, which is 25 kilowatt, divided by total energy, it is equal to 0.52 because it is efficiency. I can make total subject from here. Total will be wasted divided by 0.48. So 25 divided by W by 0.48 equal to 0.52, and then if I do algebra, I think it has to come to this because it includes all 3 of the numbers.